Out there in the cold, silent depths of our solar system, a giant sleeps, Uranus. NASA's James Webb just discovered a new moon orbiting Uranus, a world just 6 miles wide, hiding in plain sight. A world of turquoise and sapphire tipped over on its side, rolling through space like a cosmic barrel. For centuries, it has held its secrets close wrapped in a shroud of methane clouds and icy rings. We thought we knew its family, its retinue of loyal moons. We had counted them, named them, charted their paths across the sky. But we were wrong. Something was hiding, a tiny ghost dancing in the faint sunlight, unseen and unknown right before our very eyes. It was a phantom, a whisper in the gravitational symphony of the Uranian system, waiting for the right moment to reveal itself. Imagine floating in the void 7 times farther from the sun than Earth. The silence is absolute. The darkness is profound. In the distance, Uranus glows with a pale, ethereal light. Its rings, thin and dark like pencil lines drawn on black velvet, encircle the planet. But something else is there. A flicker. A tiny, almost imperceptible glint of light moving against the star-dusted backdrop of the Milky Way. It is so small, so faint that it seems impossible. A cosmic illusion, a trick of the light. Yet it persists, a secret held by the universe for billions of years. This celestial dance has been happening for eons. The giant planet spins, its moons orbit, and this little world, this undiscovered moon, has been tracing its own path in the darkness, a loyal companion that we never knew existed. It was lost in the glare of its parent planet, a firefly next to a searchlight. It was too small to be noticed, too faint to be registered by our earlier, less powerful eyes. It was a ghost in the machine of the outer solar system, a missing piece of a puzzle we didn't even know was incomplete. The universe, it seems, is always better at keeping secrets than we are at finding them. But the age of secrets is coming to an end. A new age of discovery is dawning, and it began on this day, August 21st, 2025. Humanity turned its most powerful eye toward this distant, icy realm. We weren't necessarily looking for new moons, but the universe often rewards us with things we weren't looking for. And in the data in the flood of infrared light collected from nearly 2 billion miles away, the ghost in the shadow finally gave up its secret. How did we find it? The answer is a marvel of human ingenuity, a testament to our relentless curiosity. We built a time machine. Not one that travels into the past or future, but one that looks back in time across the vast distances of space. We call it the James Webb Space Telescope, or JWST. It is a giant golden eye, 100 times more sensitive than its predecessors. It floats in the cold darkness of space, 1,000,000 miles from Earth, shielded from the sun's glare, allowing it to see the universe in a way we never could before. It sees in infrared light, the invisible heat that emanates from the oldest stars and the coldest planets. JWST was designed to peer into the dawn of time, to witness the birth of the very first galaxies. But its power is not limited to the distant cosmos. It can also turn its gaze inward, to our own cosmic backyard, and reveal details that have remained hidden for all of human history. When Webb pointed its golden mirror toward Uranus, it wasn't just taking another picture. It was conducting an autopsy on light itself. It was dissecting the faint, ancient photons that had traveled for hours to reach us, filtering out the overwhelming brightness of the planet to look for the faintest whispers of light in its vicinity. This incredible sensitivity is the key. Imagine trying to spot a single grain of black sand on a vast, dark beach at midnight. That is the challenge of finding a small, dark moon orbiting a distant planet. JWST is like having a flashlight that can illuminate that one single grain from a mile away. Its massive mirror collects every possible photon, and its advanced instruments can discern the subtlest of movements and the faintest of objects. It was this unparalleled capability that allowed scientists to spot the tiny anomaly, the moving dot that betrayed the presence of a new moon. The discovery was not instantaneous. It came after painstaking analysis of the data. Scientists at NASA's Goddard Space Flight Center pored over the images, their eyes trained to look for anything out of the ordinary. They compared multiple observations, taken hours apart, watching for any point of light that moved independently of the background stars. And there it was, a tiny speck, moving in a perfect, predictable orbit around Uranus. It was real. It was a moon, a world we never knew was there, revealed at last by our golden eye in the sky. The age of Webb is truly upon us. This discovery makes you wonder, why now? Why did we miss it for so long? Humanity has sent probes and powerful telescopes to look at Uranus before. In 1986, Voyager 2 flew past the ice giant, giving us our first and only up-close look. It discovered 10 new moons, dramatically increasing the planet's known family. Voyager 2 flew right through the Uranian system. It was there. It was in the neighborhood. And yet it completely missed this tiny world. The new moon was simply too small and too dark for Voyager's 1970 S-era cameras to detect. It was a ghost that slipped right through our net. After Voyager, we had the Hubble Space Telescope. For over 3 decades, Hubble was our workhorse for the outer solar system. Uranus its rings, its moons. Hubble even discovered a few more small moons, pushing the total to 27. It stared at Uranus for long periods, gathering as much light as it could. But even Hubble was blind to this little moon. It was lost in the planet's glare, its faint light drowned out by Uranus's brilliance. The problem is one of contrast. Finding a tiny dark moon next to a giant bright planet is one of the hardest tasks in astronomy. It's like trying to hear a pin drop in the middle of a rock concert. The planet is just too loud, its light too overwhelming. Voyager looked at Uranus in visible light. Hubble looked at Uranus in visible light. This new moon is likely very dark, perhaps as black as charcoal, reflecting very little sunlight. It was effectively invisible to them, a shadow within a shadow, hiding in plain sight. This is where the James Webb Space Telescope has the advantage. By observing in infrared light, Webb can better manage the glare. It uses advanced instruments called coronagraphs, like a tiny, sophisticated hand blocking bright light. These coronagraphs block Uranus's direct light, letting faint nearby objects show up. This technological leap let Webb succeed where Voyager and Hubble could not. The ghost was finally captured, not because it got brighter, but because our vision became sharper. So, just how small is this newfound world? The initial estimates are simply staggering. The moon, provisionally named S2025U1, is thought to be only about 6 miles, or 10 kilometers in diameter. To put that into perspective, you could walk across its entire surface in just a couple of hours. It is smaller than most cities on Earth. If you placed it on a map of New York City, Central Park, to the southern tip of Manhattan, size comparison, 6 miles versus Manhattan, Deimos, and other small moons. It is a mere speck of dust in the vastness of the solar system, a tiny chip, rock, ice, holding its own against the immense gravity of a giant planet. This makes it one of the smallest known moons in our entire solar system, Deimos, Phobos, and other tiny moons. A member of a class of objects, the tiny, leftover building blocks of planetary formation. It is likely not a perfect sphere like our own moon. At this size, gravity is not strong enough to pull it into a round shape. Instead, probably an irregular, potato-shaped chunk, pockmarked with craters from billions of years of cosmic impacts. Its surface is likely dark, coated in materials altered by eons of radiation. Imagine standing on its surface. The sky above would be dominated by the immense turquoise disk of Uranus. The sun would be just a particularly bright star, its light too feeble to provide any real warmth. The landscape around you, alien rock, ice utterly silent and frozen in time. A good running jump could launch you into a low orbit, a place of extremes, a tiny outpost on the very edge of what we consider our solar system. The faintness of this moon is as remarkable as its size. It reflects so little sunlight, one of the dimmest objects ever detected around a planet. Its discovery pushes the boundaries of what we thought was possible to see. Not just another moon. Proof our technology can find these small, dark objects lurking in the shadows. It tells us the solar system is littered with these tiny worlds, and we are finally starting to count them. Beyond its diminutive size, this new moon has another astonishing characteristic: its orbit. It whips around Uranus at a breathtaking speed. While our own moon takes a leisurely month to circle the Earth, this tiny world completes one full orbit in just 9.6 hours. It's, in a constant, frantic race around its parent planet. This means that if you were watching from a space station high above Uranus, you would see this little moon rise and set more than twice during a single Uranian day. It is a blur of motion, a testament to the powerful gravitational pull it experiences so close to the giant planet. This rapid orbit places it in a very crowded neighborhood. It orbits within Uranus's inner ring system, joining a chaotic family of other small inner moons discovered by Voyager 2, Cordelia Ophelia Bianca. These moons are known as shepherd moons because their gravity helps to shape and maintain the planet's thin, dark rings. They act like cosmic sheepdogs, herding the particles of the rings into narrow, well-defined lanes. This new moon is now the newest member of this exclusive club, playing its own small part in sculpting the beautiful and delicate ring system. Its close proximity to Uranus and its rings means it lives a dangerous life. This region of space is full of debris. From tiny dust particles, larger chunks of ice, the moon is constantly being bombarded by micrometeoroids. Its fast orbit also means it is in a delicate gravitational dance with its neighboring moons. A slight nudge from a nearby moon could, over millions of years, alter its orbit, sending it crashing into the planet or flinging it out into the darkness of space. It is a survivor, a tiny world that has managed to hang on in a violent and chaotic environment for billions of years. Studying its orbit will give us invaluable information. By precisely measuring its path, we can learn more about the gravitational field of Uranus itself. We can better understand the mass and distribution of the rings, and we can unravel the complex interactions between all the inner moons. This one tiny object acts as a probe, a natural satellite that helps us map out the forces at play in this distant system. It's honestly a key that can help unlock some of the longest-standing mysteries of Uranus. The little moon that could is now teaching us more about the giant it serves. The discovery of this tiny moon fundamentally changes our picture of the Uranian system. Before this, we had a neat count of 27 moons. It was a complete family portrait, or so we thought. Now we have to add a new face to the picture. This new face suggests the portrait is far from complete. The family is larger, more complex, and more mysterious than we imagined. The addition of S/2025U1 redefines what a planetary system can be. It shows these systems are filled with many small bodies, not just a few big ones. Let's compare this newcomer to its siblings: Miranda, Ariel, Umbriel, Titania, Oberon. These five are hundreds of miles across, spherical, geologically complex. Then the smaller inner moons discovered by Voyager and Hubble, mostly 20 to 100 miles wide. This new moon is only 6 miles across, a tiny, unique baby of the family. It likely shares origins with Uranus's rings and other inner moons. They may not be primordial, instead remnants of a shattered larger moon. Billions of years ago, that parent could have been smashed by a comet or an asteroid, or torn apart by Uranus's gravity. The debris would spread into rings and reassemble into many small moons. This new moon is a tiny piece of that violent history. Another clue: finding it helps us piece together that violent past. By studying its composition and orbit, we can test the collision idea. Run simulations to see if a shattered moon could make what we observe, including a 6-mile fragment in this orbit. Every new moon, however small, is another clue. It's another witness to solar system history. The family portrait of Uranus is growing, and its story is one of violence, destruction, and rebirth. You might ask, so what? It's a tiny rock, nearly 2 billion miles away. Why does finding one more small moon matter? Well, it matters because it represents a fundamental shift in our ability to explore the cosmos. This discovery is not just about the moon itself. It's about what its discovery means. It's a proof of concept. It demonstrates that the James Webb Space Telescope has the power to find these incredibly small, faint objects that were previously beyond our reach. If it can find one, it can find more. This is likely just the first of many such discoveries to come. This opens up a whole new frontier in planetary science. We have long suspected that the giant planets like Jupiter, Saturn, Uranus, Neptune are orbited by swarms of tiny, undiscovered moons. These are the last unexplored territories of our solar system. They are the cosmic gravel left over from the formation of the planets. We just couldn't see them. Now we can. This discovery is the first step in taking a complete inventory of our solar system, from the largest planets down to the smallest bits of orbiting debris. Every object we find tells us more about how planetary systems form and evolve. Furthermore, these tiny moons could be important for future exploration. While we have no plans to send a mission to land on this specific moon, studying it from afar helps us understand the environment around Uranus. These small bodies can be sources of dust for the planet's rings, or they could pose a hazard to future spacecraft. Knowing where they are, how many there are, and what they are made of is crucial for planning the next generation of robotic missions to the outer solar system. This tiny moon is a signpost, pointing the way toward a more complete understanding of the challenges and opportunities that await us. Ultimately, it matters because it fuels our curiosity. It reminds us that there are still mysteries to be solved, right here in our own cosmic neighborhood. For every question we answer, the universe presents us with a dozen new ones. We thought we had Uranus figured out, but this tiny moon proves we've only scratched the surface. It beckons us to look closer, to push our technology to its limits, and to continue the grand human adventure of exploration. That is why one tiny moon, a mere 6 miles wide, can change everything. It expands the boundaries of our knowledge and inspires us to keep looking up. Every time we build a new tool for looking at the sky, our universe gets bigger. Not in physical size, but in richness, in complexity, in wonder. Galileo's first telescope revealed new details. The moon had mountains, Jupiter had its own moons. Those discoveries shattered the old Earth-centered view. Hubble showed us the scale of the universe, its billions of galaxies stretching back toward the dawn of time. Now the James Webb Space Telescope is giving us another new universe, a universe seen in the invisible light of heat, revealing hidden structures and secret worlds. This tiny moon around Uranus is a symbol of that new perspective. It shows even familiar places hold undiscovered wonders. Our solar system is more dynamic, more crowded, more interesting than we thought. Old textbook diagrams are being redrawn in real time. The story of our solar system isn't a closed book. We're still writing the first chapters. And JWST is our powerful new pen. This is the essence of science. Continuous discovery, peeling back one layer of reality to find a more intricate layer beneath. We are explorers on an infinite ocean, once stuck on the shoreline, seeing only the biggest, brightest islands. Now Webb is our vessel into deep, uncharted waters, finding tiny, hidden atolls. Each discovery, however small, adds a point of light to our map. So look up and remember this little moon, a 6-mile wide world racing through darkness nearly 2 billion miles away. The universe isn't empty. It's filled with secrets, from the grandest galaxies to the tiniest moons. We, on a small blue planet, have built an eye that can see them. The cosmos is inviting us to look. With JWST we accept. The view is more magnificent than we could have dreamed.